Greetings. So in this video, we have a exponential functions word problem. So in this situation, we have a colony of bacteria, pretty typical type of situation for an exponential function. And this colony grows exponentially. So suppose that we started some experiment at noon with 13 bacteria, as shown in this table here. And then we also recorded the population 2 hours later at 2 p.m. And that population was 1053. The question is, how many bacteria would we expect to see at 2:30? So the key to this one is being careful with defining your variables, right? So we're going to make a function here, an exponential function. So y equals ab to the x, or depending on what letters you prefer to use, b times m to the x. Again, all that matters is that this green guy is the multiplier, and this yellow guy is our y-intercept or starting value. Okay, so I'm going to try to define my variables this way, and you can define it other ways as well. And maybe I'll do kind of two different ways of doing this because I think this will go kind of fast. But we're going to say y, well, for this column here. So y is going to be our number of bacteria. Okay, and of course x will represent our time. But we want to be really specific about where this time starts. So I'm going to say time since we started the experiment. We don't actually know when we started the experiment, but that's actually not really relevant. What is important is what our time is when we get to actually representing 2:30. So I'm going to say that our x represents time since noon or 12 p.m. And I'm going to assume that the units are in hours. This can be done in other ways. There's no reason you couldn't do minutes or half hours if you want, but I'm going to use hours here. Okay, so if that's the case, then I really have this as x, and this would now be x equals 0, and 2 p.m. is 2 hours after that, so that would be 2. So my 2 points now are 0, 13 and 2, 1053. This means that I actually have my starting value. So I already know my equation, at least part of it, is 13 times my multiplier raised to the x power, whatever that multiplier happens to be. And we can actually just plug in the second point, 2, 1053, to actually get that multiplier. So I'll do that. 1053 equals 13 b squared. If I divide this by 13 and this by 13, I will get 81. I did this scratch work already on the side. And therefore my multiplier is 9. The square root of 81, which is 9, here. Okay, so that's cool. And now that if I'm plugging in 2:30, that is really saying that x is equal to, well, 2.5 hours since 12, so that'd be 2.5. Okay, so now I have y equals 13 times 9 to the 2.5, and I don't have a calculator for this problem. At least that was the intention, is that I don't have a calculator. So how am I supposed to do this? Well, if I have this exponent as a fraction, I would know what to do. So I'm going to convert 2.5 as 5 halves. 13 times 9 to the 5 halves. And now I know what to do, because 5 halves is really, 9 raised to the 5 halves is also known as the square root of 9, and raise that to the 5th power. So that's just 3 to the 5th, which is, I believe, I don't remember that one off the top of my head. That's okay. I have 5 3s. The first two make a 9. The next pair make a 9. So that's 81. I still have one more 3, so that is 243. So this is really 13 times 243. We're going to do a little bit of scratch work on the side, or I can just take out my calculator because you don't want to see that scratch work. That'd be kind of boring. That calculator doesn't work. This calculator doesn't work either. Please work. Aha, I found one that works. 13 times 243 is 3159 bacteria. But I did say that you don't have to define your x in hours, so let's try another way. So what if I define my x as half hours or 30-minute intervals? Well, that's totally fine. So I'm going to recopy my table here. So noon will still be my starting time. we had 13. And then so that's noon. At 2 p.m., that'd be 4 half hours later. So that would be 4. And then at 2:30, that would be another half hour, so 5. Okay, so 10:53 right here. I can still find my multiplier the same way as I did before. So y equals 13 times b to the x. I'll plug in this point to get 1053 is equal to 13 times my mystery multiplier raised to the 4th power. Just like before, I'll divide by 13 and get 81. And therefore, b is the 4th root of that, which is 3. Okay, cool. So now, if I want to plug in x equals 5, my equation is 13 times 3 to the 5th. Now notice this just kind of shortcuts what we did here. So that part is all the same actually. 3 to the 5th is going to be 243, and so I don't think I need to go through all of those steps again, just to show that the answer is indeed 3159. Okay, so I hope that helped. In case you were at all confused, thanks for watching. I'll catch you later.